7 बज गए, कोई नहीं है. We are live now. We are live now. We are live now. We are live now. Hello, my dear friends. Hello, 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 hello. So today, we are going to do another lecture on the photoelectric effect series. We are doing another lecture on photoelectric effect series. Okay. This is what we are going to do today. This is what we are doing, and this is what we are going to do today. Okay. Yes, 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 yes. This is what we are doing today. Photoelectric effect. Photoelectric effect. About me, about me, about me, about me. So my good name is Raghav Sharma. Raghav Sharma. 3 years of teaching experience of NEET has taught many students. So MSc in Physics, BSc Physics Honors, B.Ed, published an international article in Journal of the American Ceramic Society, and done research work in JNU with renowned researchers. Okay, so this is about me, and if you want to, you can just Google me and you will find me. Okay. After good evening, Mariam, Fatima, good evening. So do tell me how's the preparation of the exam going on? How's the preparation of the exam going on? If it is going bad, then rate it 1. If it is going okay, then rate it 2. And if it is going fine, if it is going good, then rate it 3. 1, 2, 3, it's on you that how is going on. You should test yourself. You should test yourselves. How are you? For that, you should do what? To test that. How can I test that I'm bad, I am doing okay, I am doing very good. What you should do? You should do previous year paper. Have a previous year paper and try to do it by yourself and see what is your score. What is your score? If your score is below 600, if your score is below 600 out of 720, good evening, Ahmed. If your score is below 600, okay, this is for whose score is below 600. This for those whose scores is around 600 to 680, and this is for those whose scores is 680 plus. Try to do previous year question. Try to do previous year question and to check yourself. Are you in this category, or are you in this category, or are you in this category? Okay. So test the water that how are you? Okay. How's the preparation of the year going on right now? After this. So what is our goal today? What is our goal today? What we are going to do? So first, we are going to do the recap. Okay. First, what we have done in the previous lecture. So I will give you a little recap. Okay. Then we will talk about photocurrent and plot a photocurrent with anode potential. And then we will talk about stopping potential and its graph versus frequency and wavelength. Okay. And then we will do intensity, photocurrenting, stopping potential, and that it will complete our what? Photoelectric effect. That will complete our what? Photoelectric effect. And tomorrow at on the Republic Day. Yes. Tomorrow is what? Tomorrow is Republic Day. And tomorrow we will do what? Tomorrow we will do de Broglie hypothesis. Tomorrow we will do what? Tomorrow we will do de Broglie hypothesis. And this, before starting, make sure you are sitting with pen and paper. Okay, you have pen and your paper, because we are going to do questions. We are going to do some previous year questions. We are going to do that. Okay, we are going to do that. We are going to do the previous year questions. So make sure you are sitting with pen and paper. That thing is important. So first, let's talk about some Altedemy. Let's first talk about Altedemy. Before starting all this, let's talk about our Altedemy. Okay. So we have a channel on Telegram as NEET, where we give PDF materials, free classes, notifications, do various announcements related to our courses, and do discounts and prices, and do sometimes giveaways too. Okay. What we if you join that channel, you can have free PDF material. Okay. PDF material, you can just message me. And I will give you. Okay. And free classes announcements. We are doing this free classes, so you will have notifications for that. We also do announcements and discounted prices. Okay. Discounted prices. Some student got our main classes course on free. Okay. After that, make sure you do sub the channel. You do subscribe the channel, because subscription is important for the channel growth. So make sure you subscribe us. After this, let's talk about our course that we are doing. So we are doing 90 plus classes on every subjects. Okay. That is convenient education platform. You can just let's see us in laptop, in PC, in Android, in iOS. Whatever you have, you can access us. Whatever you have, you can access us. Syllabus is made from me and other NEET experts. We have flipped classroom method, which we'll talk about at the very end. This thing we will talk about at it very end. Flipped classroom method. And what we have doubt solving practice, DPPs, that are very important. So make sure you do DPPs, and you have previous year questions also. So you have all that thing. You can have 90 plus classes. You can have convenient education platform. Syllabus made from NEET expert, that is concise and concentrated. No extra thing. The thing that you want, that there is flipped classroom method and doubt solving practice. What more you want? We have everything. After this, we have 3 types of plans. We have light, we have smart, and we have professional. Light, smart, professional. In light, smart, professional, you will have indirect live classes, that our main classes, structures, course, and PDF that you can have. Live test, we have physical notes that we have. In smart and professional, what extra you will got? You will get one-to-one mentorships, live doubt solving. You will get mock test regularly. You will get three things extra. Mentorship is necessary. You are going in a different route, in a different place. So mentorship is like they will guide you like a Google map. And live doubt solving, that is also important. Mock test, they are also important. Testing the water. How are you? How actually good are you, and how actually bad are you? You should know by yourself. Okay, you don't have to lie with yourself. You should know how are you in the things are. If you are bad, then you are bad. If you are good, then you are good. Mock test. And if you want some motivation, then you can go from professional. I will motivate you and keep you on track. Okay. Keeping on track is important. After that, let's start our course. First of all, what we have studied, what we had done. So we are going to do a quick recap of previous lectures. If you are new and if you are joining this first time for Photoelectric effect, first, what we have done, we had done work functions. What is work function? We talk about, let's say there is a plate. We are doing this in a fast way. Okay, let's say this is a metallic plate. This is a metallic plate. This is a metallic plate. And in this metallic plate, there are free electrons. And there are photon came. Okay, of energy. What? Let's say energy is h mu. Energy is h mu. So this h mu energy, there is a free electron, and this electron is binded by what? This electron is binded by the metal. So it will gain some energy from this, and with leftover energy, it will escape. And that will be h mu minus mu naught. Okay. The energy which is needed to get removed from the surface is called what? Is called work function. Is called work function. It's called work function. If we write so that this energy h mu is equal to what? Work function, and plus this energy is what? Kinetic energy max. This is kinetic energy max. Okay, kinetic energy max. So this is what we have done. So h mu, the energy, the photon came strike the metallic surface, and this electron, what it done? First it absorbs some energy to broke the bond from its atom. After it had broke the bond, with remaining energy, it has gone with this energy. This is called the kinetic energy max. So h mu is equal to phi. This is called work function. This is called work function. Okay, this is called work function. This is the maximum kinetic energy, Ke max. This is the Ke max, kinetic energy max. Okay, so we have what? We have h mu is equal to work function plus kinetic energy, maximum kinetic energy. We have this. Okay, we have this. So kinetic energy max can be written as what? Okay, can be written as can be written as phi minus this energy h mu. Okay, simple. This thing is simple. This is the what? This is the threshold. This is the threshold energy that it requires. So it will written as h mu naught. H mu. Okay. So h common. What I have done wrong? Phi is equal to h mu minus E minus phi. I have done this. Why are you telling me, sir? You have just doing basic things wrong. Why are you doing this to me? Okay. So kinetic energy max will be this is E. This will be E minus phi. Kinetic energy max E minus phi. E is h mu, and this is h mu naught. H mu minus mu naught. This thing we had done. This is kinetic energy max. Okay. So this mu naught is called threshold frequency. This is called threshold frequency. If frequency of the photon that is striking on the metallic plate is lower than this, then the electron is never going to be emitted. If this mu has to be greater than mu naught. This mu has to be greater than the mu naught for emission has to be done. This mu has to be greater than mu naught. This thing we have already done. This mu has to be greater than mu naught, and this mu naught is called what? Threshold frequency. This mu naught is called threshold frequency. Are we clear? Are we clear, my dear friends? Okay, yes. Okay, yes, we are right. After that, we are talk about threshold wavelength. We know that Ke is what? H mu minus H mu naught. And mu naught is what? Frequency is what? C by lambda. So we can write it as Hc by lambda minus Hc by lambda naught. And if we take Hc common, it will come out of 1 by lambda minus 1 by lambda naught. If we take that Hc common, this lambda naught is called what? This lambda naught is called threshold wavelength. This lambda naught is called threshold wavelength. And for emission has to be happen. For emission has to be happen, this lambda has to be shorter than what? Lambda naught. For emission has to be happen. For emission has to be happen. This lambda, okay, this lambda has to be lower than threshold lambda for photoelectric effect to be happen. How? Just imagine, imagine this is inverse. 1 by lambda minus 1 by lambda naught. 1 by lambda minus 1 by lambda naught. So for this, the condition is opposite to that of frequency. The condition is opposite to that of what? The frequency. Condition is opposite. Condition is opposite to that of frequency. Condition is opposite to that of frequency. Lambda has to be lower than the lambda naught. Means wavelength has to be lower than the threshold wavelength. Okay. Now let's do the question. Question time. So make sure you are sitting with pen and paper. Make sure you are sitting with pen and paper. So first thing first, photoelectric emission occurs only when the incident light has more than a certain minimum. Okay, photoelectric emission occurs only when it occurs. When it is going to occur, it is going to be A, power, P, wavelength, C, intensity, D, frequency. A is wrong, C is wrong. Wavelength or frequency, what is going to be? What minimum? Okay, what minimum? If it is maximum, for minimum it is frequency, and if there were maximum in the question, then the answer will be what? Wavelength. Okay, incident line has to be certain frequency. It has to be certain frequency. Okay, it has to be some certain frequency to do what? To do photoelectric emission. Okay, and if there was in this question, if in the place of minimum, if there were maximum, certain maximum, then the answer should be what? The frequency. Sorry, wavelength. Then the answer will be the wavelength. So the answer for this is what? Frequency. Answer is frequency. If in this question, question, in place of minimum, if it was maximum, then the answer will be what? Then the answer will be what? Wavelength. Then the answer will be B. In this question, so the right answer for this frequency. Okay, pretty easy question. Photoelectric emission occurs only when the incident light has a certain minimum frequency. Certain frequency, h mu, certain minimum energy. It will have some certain minimum energy, then it will do emission. Okay, and E is equal to hc by lambda. Okay, opposite of this minimum, and that will be what? That will be maximum. Frequency minimum, wavelength maximum. After this, what we have? This is a easy question. NEET 2015. Easy question. A photoelectric surface is illuminated successfully, okay, by monochromatic light of wavelength lambda and lambda 2. Okay, we have a surface and we are illuminating it with two lights, one with the wavelength lambda and one with the wavelength lambda 2. If the maximum energy of the emitted photoelectric emission, okay, is 3 times that in the first case. Okay, in this case, kinetic energy is 3 times of this case. Then he is asking for the work function in terms of hc by lambda. He is asking for what? hc by lambda. He is asking for the hc by lambda. Let's have you seen the question? Pretty easy question. Okay, let's try to do it. Okay, make sure you're sitting with pen and paper because you are going to need it. We are doing the question time. So you already read the question. Now let's do the question for the first condition. So he's asking what is saying the kinetic energy in first condition is what? hc, and lambda in first condition is lambda. Okay, is lambda, and that will be minus phi. Work function is going to be same in both cases. In first condition, this is ke for the first condition. Let's write for the ke for the second condition. hc, and lambda is lambda by 2. Work function is going to remain same. So this is second case. Okay, this is second case. Now this ke2. Okay, this ke2 is 3 times of ke1. This ke2 is 3 times of ke1. So we have to put this ke2. So this will be 2. Okay, this 2 will come up. 2 hc by lambda minus phi will be equal to 3 times of this. 3 hc by lambda minus 3 phi. What we have to find? We have to find the phi. So 2 and 3 times, this will be 1 hc by lambda will remain here, and phi minus 2 phi equal to 0. Okay, so the phi will be 2 phi will be hc by lambda, and phi will be hc by lambda 2 lambda. hc by 2 lambda. Pretty easy stuff. Okay, hc by 2 lambda. Option number C. After this, try to do this question. When the energy of the incident radiation is increased by 20%, we have increased the radiation power by 20%. Radiation increased by 20%. The kinetic energy of the photoelectrons emitted from a metal surface increased from 0.5 to 0.8 electron volt. So when we increase the incident radiation by 20%, it increased the kinetic energy from 0.5 electron volt to 0.8 electron volt. So we have to find what? We have to find the work function again. We have to find what? We have to find the work function again. How we do it? We have the formula. Okay, try to do with me. Try to do this question with me. We know on the first condition, we know that kinetic energy max is equal to what? H mu minus phi naught. Okay, on the initial condition, kinetic energy was 0.5 electron volt. Okay, kinetic energy was 0.5 electron volt. So first condition 0.5 electron volt. Okay, and this is 100%, so 1 h mu minus phi naught. First condition. Now second condition, it increased to what? 0.8 electron volt. 0.8 electron volt. When it increased the radiation by 20%, so it will be 1.2 h mu minus phi naught 2. Now can you solve what will be the this? How can we do it? How can we do it? Can you do it now? We have to find phi naught. Phi naught. We have to find this. We have to find the work function. We have to find phi. We have to find phi. Can you do that now? Can you do that? Can you find the phi naught? Can you? Anyone? What will be the phi? What will be the phi? Anyone? What we can do? We can multiply this equation by 1.2. We can multiply this by 1.2, and then we can substitute the value of 1 by 2 HU. Then we can subtract 1 from 2 and from 2 from 1, and we can find it. We can find it. Okay. And what we will get? What we will get? Phi naught will be, I have done that. Okay, that will be 1.0. That will be 1.0 electron volt. Phi naught will be 1.0 electron volt. Just the simple mathematics. Just the simple mathematics. Okay. Just the simple mathematics. Simple mathematics. Okay. That will be 1.0 electron volt. That will be 1.0 electron volt. Pretty easy stuff. Pretty easy stuff. One condition, second condition. Find the phi. Find the phi just by simple substituting. We can do it. Substitution. We can do it. Similar to this question. Similar to this question. Okay. Pretty easy question. Okay. Questions on this topic are easy. Okay. Questions on this topics are easy. You just have to know some basic mathematics. If you know some basic mathematics, questions of this topic are very easy. Are very easy. Now just see this, how easy this question is. Just see how easy this question is. NEET 2030. Just see how easy this question is. Okay, do give a read. For photoelectric emission from certain metal, the cutoff frequency is mu. Okay, if radiation of frequency 2 mu impinges on the metal plate, the maximum possible velocity of the emitted electrons will be. What will be the maximum velocity? He's asking the question on the formula. He's saying we have the formula like this: kinetic energy max. What is this? H mu minus phi naught. He's saying he's impinging with the radiation 2 mu. Is impinging the metal with the what? Radiation 2 mu. Okay, 2 mu. So this mu is 2 mu. And the cutoff frequency is mu. So this is, and mu dash is 2 mu. So phi is h mu naught, and this mu naught is mu. Cutoff frequency is mu. Cutoff frequency is h mu. H 2 mu minus kinetic energy max. And what is kinetic energy? Is nothing. Is half mv square. Is asking for this v value. H 2 mu minus h mu. 2h mu minus h mu is h mu. Easy. And this half 2mv square. So v square will be 2h mu upon m. So v will be what? 2h mu upon m. Simple mathematics. Just see how easy the question is. So 2h mu upon m. So I think the answer is A. Answer is A. 2h mu upon m. 2h mu upon m. Just see how easy the question is. 2h mu upon m. After this, let's do this. Okay. Now let's do our topic. Photocurrent. Okay, photocurrent. See, this is called the photocells. photocell. This is called what? This is called photocell. This is called photocells. With this, a variable voltage we can give it. So we will give it with a rheostat. Okay. The symbol for rheostat is this, RH, and a battery is connected with it. A battery is connected with it. Okay, let's make this beautiful. Make this beautiful. Okay? Make this thing beautiful. Line, and this is our rheostat. So first, let's see the diagram of the rheostat. Very easy stuff. Okay, rheostats. For varying the voltage, with rheostat, what we do? With rheostat, what we do? We just vary the voltage. Okay, this is called rheostat. Positive terminal, negative terminal. So what we have made? We have made the photocell. Photocell, okay, photocell. And here just connect a ammeter. Let's connect here an ammeter. Ammeter, rheostat. This is cathode. The negative terminal. So that is connected is called cathode. Positive terminal is called what? Anode. Negative terminal is called cathode, and positive terminal is called what? Anode. This is also called as anode. This is also called as collector. This is also called as collector, and this is also called as emitter. Cathode. Cathode another name is emitter, and anode another name is collector. Emitter, collector. So what we are doing, we have a source. We have a source. Source of what? Source of what? Source of radiation. Not source of radiation, we can say electromagnetic wave of the light. We have a source of light. We have a source of light. Source of light. This is a photocell. This is a quartz window. So through this quartz window, light is coming and striking the cathode. Light is coming and striking the cathode. It striked, bang. It striked and bang. What will happen? A photoelectric emission will happen. Now what will happen? From this source, light has come, okay, and strike the cathode. What will happen? Now? A photoelectric emission will happen. Okay. So this light has to be for photoelectric emission. This light has to be of short wavelength, or you can say of high frequency, So light of short wavelength or light of high frequency is made to fall on what? Metal plate C. When it will happen? What will happen? Electrons are going to be emitted. From the C plate. Okay. And there is a potential difference. So they will be accelerated towards A. Electrons from C will get collected in A. There will be electron movement. There will be what? There will be an electron movement. If there is electric movement, okay, there is electric movement, what will happen? If there is electric movement due to this ammeter will start to show what? This ammeter will start to show deflection. And when ammeter start to show deflection, what it means? It means there is a current in the circuit. What it means? It means there is a current in the circuit. And that current in the circuit will be called as what? Will be called as photocurrent. That current in the circuit is called what? Photocurrent. That current in the circuit is called photo current. Are we clear? Okay. Is that clear? Is that clear? Is that clear? Is that clear? Okay, is that clear? After this. So the potential difference between C and A can be maintained with the external battery and the rheostat. A potential difference can be created. Yes, we are going to create. We have the rheostat, we have the battery. So there will be what? There will be a potential difference. There will be a potential difference between them. So there are electrons are going to imitate. They will going to accelerate towards A. They are going to accelerate towards A. They are going to accelerate towards A because of the potential difference. After this, the anode is given a positive charge with respect to cathode. Yes, we know that electrons moves towards anodes, passes through external circuits and back to the cathode. Yes. The whole thing is happening. It is going like this again and moving like in a circuit. This electron is going to move in this circuit. This electrons first gone from this and going to move in this circuit. Yes, we know it. Yes, we know it. And this current is called what? This current is going to call what? This current is going to call photo current. This current is going to call what? Photo current. This will be the electron movement. This will be the electron movement he is talking about. This is the electron movement he is talking about. So there is going to be the electron movement in the circuit. There is going to be the electron movement in the circuit, and due to this electron movement, there will be a current, and that current will be called as what? Photo current. That current will be called as what? Photo current. Now very interesting stuff. Now very interesting stuff. Just listen carefully. Very interesting stuff. Okay. This will clear many things. Now look here. Now the photo current is in the ammeter. It is showing. This is electron. This is electron. Between electrons there is what? We have two electrons, and between electrons there is a what? Coulombic force. There is a what? Coulombic force. There will be a repulsion between them. There will be what? There will be a repulsion between them. This is one electron. One electron wants to strike another. Okay, they will both want to go to anode. They will both want to go to what? Anode. They will both want to go there. But this electron that is in front, that is here. That will repel this. That electron will repel that electron. That electron will repel that electron. He will say, वापस जा. यहाँ तेरा काम नहीं है कुछ. So he will say that. There's electron here. There's electron here. So this thing is called what? This thing is called space charges. Okay. This negative charge repel the fresh electron coming from cathode. Okay. So this electron that is between the cathode and anode, that electron which is between cathode and anode will repel this electron that is in plate, that electron that want to come out. The electron that want to come out, and there are electrons in this between cathode and anode, they will repel that electron. So what is the solution for this? What we can do? We can increase the anode potential with respect to what? Cathode. We will increase the anode potential with respect to cathode. So we can counter this. And when we do that, photo current increases. When we do that, what will happen? Photo current increases. And what we see after a certain time, the photoelectron will become constant. Now the photo current become constant, and we are increasing we are increasing the anode potential more and more and more and more and more. We are increasing the potential more and more. But for a photocurrent is not increasing. Why? Why? We are countering the Coulombic force. Number of electrons are constant. Number of electrons are constant. Okay, number of electrons are constant. We are not increasing that. They are constant. So what we are countering the Coulombic force, or the repulsion that is happening between what? That is happening between the electrons. That is happening between the electrons. By increasing the potential, we are counting that, but we are not increasing the number of what? Potential. Okay. Are we clear on that? Are we clear? Are we clear with the story? Are we clear with the story? What is it all about? What is it all about? When we increase the anode potential, it will counter the Coulombic force that is happening between the electrons. That is happening between the electrons. It is going to counter that. It is going to counter that. Okay. Okay. On the other hand, if you know, okay, if what we will do, on the other hand, if anode is given negative potential, now we have given the anode. This is anode. Okay. Now this is cathode. This is anode. This is anode. This is cathode. Anode is at now is a negative potential, and this is at positive. This is at positive. Now if we keep decreasing, when there is a zero potential difference between them. When there is zero potential difference, there is also current between them. There is also a current on that condition also when there is zero potential. But we even keep on decreasing the potential. Anode negative, cathode positive. Okay. When we are striking the cathode with what? You're striking the cathode with what? With light, and there will be emission of the electrons from it. To counter this emission, we have to apply a negative potential. So what will happen? There will be no emission from the cathode. And that potential, that negative potential, when there is no emission of the electrons from the cathode, that is called as stopping potential, or that is called as stopping voltage. Stopping potential or stopping voltage, you can say at whatever you want. So if we keep decreasing anode potential, making more and more negative, a stage comes when no electron can reach A and photocurrent becomes zero. This anode potential, which stops any electron from reaching anode, is called what? Stopping potential or stopping voltage. Okay. So if we plot that, what is the graph going to look like? What is the graph going to look like? Okay. What is the graph going to look like? The graph is going to look like this. Say in this direction there is the photocurrent that is I. Photocurrent that is I. And in this direction this is anode potential. And this is our stopping potential we want to find. So this will be look like this. This is going to be look like this. This is going to look like this. Something like this. Something like this. So this will be called as stopping potential. This will called as what? Stopping potential. Stopping potential. This we note. At this potential, there will be no photoelectric emission from what? From the cathode. From the cathode. And this after this is called what? This is called what? Saturation current. This is called what? Saturation current. Keep increasing the anode potential, there will be no increase in photo current. This is called what? Saturation current. That is called as saturation current. Okay. Now talk about the stopping potential. Now let's talk about the stopping potential. If we write the definition, the definition will be the smallest magnitude of anode potential which just stops the photocurrent is called the stopping potential. Is called the stopping potential. Is called the what? Stopping potential. Is called the what? Stopping potential. Okay. So the minimum potential for which even the fastest electrons fails to reach anode is called what? Stopping potential. Okay, stopping potential. The kinetic energy is used in doing work against electrostatic force. Okay, that force. Electrostatic force. Ke max will be q delta v. Okay, q delta v. We know it. So after this, Ke max for the kinetic energy of the faster electrons, we have Ke max is equal to K Q delta V, and kinetic energy max, we are talking about electrons, so this will be E V delta V naught, stopping potential. So stopping potential will be kinetic energy max upon E. So do remember this. Important stuff. Do remember this. This is important thing. You should not forget that thing is important. Now let's talk about stopping potential versus frequency of incident radiation. Let's talk about stopping potential versus frequency of incident radiation. Stopping potential is what? We have talked about Ke max. We have just talked about Ke max upon E. This is E upon E minus phi upon E. Ke max upon E upon E minus phi upon E. So V naught will be, this is what V naught. This is V naught, and this is H mu by E minus H mu naught upon E. Mu upon H mu naught upon E. So this will be what? This is our stopping potential in terms of frequency. Okay. H mu. If we talk about so mu naught will be This will be h by e, h by e, h by e into mu minus h by e upon mu naught. If we plot it, this will be our y, this will be our m, this will be our x, and this will be our c. H y is equal to mx plus c. We can plot it. Let's try to plot it. So this is frequency and this is our potential, stopping potential. This will be our, oh, what happened? This will be our stopping potential. This will be our stopping potential. Okay. Graph will be like this. And this will be pi upon e. This will be this will be pi upon e. This will be pi upon e. This is going to be f naught, and the slope for this theta, the slope for this will be h by e. Are we clear on that? Just this plotting the graph y is plotting the y equal to mx plus c. Just plotting the mx plus c. Y is equal to mx plus c. Just plotting this stuff. After this, if we graph this, if we stopping potential versus wavelength, similar stuff. We know that Ke max is equal to E minus phi. This is E V naught. E minus phi. V naught will be E by E minus phi upon E. And if we E is equal to h mu, if we convert this to V naught will be hc by E lambda minus hc upon E lambda naught. This is phi upon E. Okay, it's phi upon E. hc by E lambda naught. Again we can plot it. In a similar way. V naught will be our y. Okay. hc by E will be our m. 1 by lambda will be our x plus, and this phi upon E, or you can say hc by E lambda naught will be our c. Y equal to mx. Oh, I have done so. This will be I minus. We are plotting for this. So y equal to mx, not positive, this is negative. Okay. Yes, I've done this there right. So if we plot it, plot will be like this. Plot will be like this. Straight. This is 1 by lambda. This is stopping potential V naught, and this will be like this. This will be 1 by lambda naught. Okay. Slope will be hc by E in this condition. Slope will be hc by E. This is will be in this we have 1 upon lambda. Okay, this is 1 by lambda, inverse of lambda, and this there is stopping potential. Again, this will be phi upon E. This length will be phi upon E. This length will be phi upon E. Now let's do some question. Question time. Let's do some questions. Now let's do some questions. Do give a read. Okay. Do give a read. Photons with energy 5 electron volt are incident on a cathode. photons with energy 5 electron volts are incident on a cathode C in a photoelectric cell. The maximum energy of emitted photoelectrons is 2 electron volt. First condition. This is our first condition. Next condition. When photons of 6 electron volt are incident on C, no photoelectron will reach the anode A if the photostopping potential is what? So we have to find the stopping potential. First condition we have given. We have kinetic energy max. We have incident energy. Incident energy we have the kinetic energy. We can find the what? Work function. From here we can find the work function. Let's find that. So in this condition, Ke max will be incident energy, okay, minus 5. First condition, Ke max is what? 2. Energy is what? 5. And this is 5. So 5 will be 3. And this whole thing is in electron volt. So 5 is 3 electron volt. We had the 5. Now what do we have to find? We have to find the stopping potential. Then what is saying, when photons of energy 6 electron volt are incident. Okay. What are the incident energy? 6 electron volts. So what will be the kinetic energy on this condition? 6 minus 3. So the kinetic energy of those electrons will be 3 electron volt, kinetic energy max. Now we know kinetic energy. Okay, now we know kinetic energy upon E is stopping potential. We know it. Kinetic energy is 3 electron volt upon E upon V naught. E cut, so stopping potential will be 3 volt. Now we know it. So V naught will be 3 volt. Okay, and we are stopping potential negative minus 3. D. Answer will be P. Good evening Adhyan. Good evening. Next question. A certain metallic surface is illuminated with the monochromatic light of wavelength lambda. The stopping potential for photoelectric current for the light is 3 V naught. Okay. If the same surface is illuminated with light of wavelength 2 lambda, the stopping potential is V naught. So we have to find the threshold wavelength in terms of lambda. What is saying? A certain metallic surface. What is saying? A certain metallic surface is illuminated with this wavelength. Okay. The stopping potential for photoelectric current for this light is 3 V naught. For this wavelength lambda, the stopping potential is what? 3 V naught. Again, if this same surface, now on the second condition, if the same surface is illuminated with the wavelength 2 lambda, same surface, and we are giving it a wavelength 2 lambda, then the stopping potential is V naught. In second condition, if lambda, then stopping potential is 3 V naught. If lambda, wavelength 2 lambda, then stopping potential is V naught. Okay. So he's asking a threshold wavelength. He's asking for this lambda naught in terms of lambda. He's asking for lambda naught in terms of lambda. Good evening Adhyan. With caution. So he's asking for lambda naught in terms of lambda. What is going to be? What is going to be? We know that lambda naught is equal to hc by lambda naught. We know it. And stopping potential. Okay. Stopping potential on first condition is 3 E V naught is equal to E minus lambda upon E. We know that too. We know that in first case. This is our first case. First case. In second case, E V naught is equal to let's solve it more. For more clarity, we should solve it more. So 3 E V naught HC by lambda minus HC by lambda naught on first condition, on first case. On second case E V naught is equal to, this lambda is now HC by 2 lambda. Okay, 2 lambda in case of this V naught. Okay, 2 naught. And this is going to be same HC by lambda naught. Second case. First case, second case. First case SC by lambda minus SC by lambda naught, 3 V naught. First case. Second case E V naught equal to SC by 2 lambda minus SC by lambda. Second case. Now we have to find lambda naught. When we do multiply this by 3, substitution, 3 V naught multiply this by 3, and when we do substitution, and then we can just equate them, and we will find that lambda naught is equal to 4 lambda. Simple substitution, if we do simple substitution, we will find lambda naught is equal to what? 4 lambda. By the simple substitution. You can do this with pen and paper. Because I have very little space to do all that stuff. So I'm just writing the answer. I can just think that you should do this by yourself. Okay. This much you can do. This much stuff you can do. After this, we have another question. A source of light is placed at a distance at 50 centimeter. Okay. From a photocell, and the stopping potential is found to be V naught. Okay. Stopping potential is V naught. If the distance between light source and photocell is 20, he's reduced the distance by half. Then the new stopping potential will be. He reduced the distance and is asking what will be the new potential. Stopping potential. What will be the new stopping potential? My dear friends, distance. Intensity is inversely proportional to the distance. If we reduce the distance, the intensity is going to increase. If we reduce the distance, intensity is going to increase. But the stopping potential is independent of intensity, so it will remain as it is. If it is V naught, then it is going to be V naught. It is independent upon the distance between the cathode and anode. It is independent of that. Stuff. After this, in a photoelectric emission process from a metal of work function this. Okay, we have the work function given. The kinetic energy of the energetic electrons, most energy electrons is 0.5 electron volt. The corresponding stopping potential is, again, very simple, Ke max. If we are talking about the magnitude, E V naught, and the energy Ke max. Ke max is 0.5 electron volt. E V naught, E cut. The stopping potential will be 0.5 volt. 0.5 volt. Very easy. We know this formula. We derive that. Okay. So pretty easy stuff. Now let's talk about intensity, photocurrent, and stopping potential. Intensity. Let's talk about intensity. How intense the thing is. Intensity. Okay. Intensity means number of photons. If we increase the intensity, what will happen? Number of photons will increase. Okay. number of photons increase, so number of photoelectrons increase. Number of photoelectrons increase. Okay, and that will make photocurrent increase. If the number of photoelectrons increase, what will happen? Photoelectron will also increase. Photoelectrons will also increase. Photoelectron will also increase. I is what? V D E N A. This is what number of electrons. Okay, number of electrons. This is density, number of electrons. If we graph it, what we will see? What we will see, this is like this. This is going to be like this. This is photocurrent I, and this is intensity of radiation. This is intensity of radiation. It will be like this. If we increase the intensity, photocurrent will increase. Photocurrent will increase. Intensity and photocurrent. Photointensity will increase. Second question I have for you. If we increase the intensity, what will happen with stopping potential? It is going to increase stopping potential. Let's talk about this stopping potential. A is going to increase, B decrease, C remains constant. What is going to happen in this condition? Stopping potential is independent of what? Intensity. So it is going to remain constant. Okay. Intensity has no effect on stopping potential. Intensity has no effect on stopping potential. Has no effect on stopping potential. Are we clear? Yes. So let's talk about our flipped classroom method. What we will do in this, we first give you theory, and in this theory we will do some previous year questions, do our stuff, and we will clear all your doubts, and we will give you study materials. In study materials there is everything that you have to know. In study material there is everything you have to know. After this we will do webinars to more clearly clear your doubts, okay, that are remaining. If they are remaining in theory, if they are remaining in study materials, if you have still have some doubts, we'll clear in it on our webinars. And then we have our homeworks that we will give daily, and we do check them. We have our faculties that are sitting, and they are going to scold you, and if you are not going to do that, they are going to scold you if you are not going to do that. And see you soon. See you tomorrow in our lectures, de Broglie hypothesis. See you on the lecture tomorrow on the de Broglie hypothesis, 5 p.m. And in advance, happy Republic Day. Bye.